Hello friends, in this video I'd like to talk you through how to determine or make an estimation of the experimental endpoint and therefore the corresponding theoretical equivalence point for two different titrations done by monitoring the pH versus volume of titrant. So I'll assume that you have already recorded your data, the concentration of your standard NaOH, the volumes of each of the acids that are or that were used, and here you've made your plot of pH versus volume of titrant. Now, there are a number of different approaches to get an estimation of the endpoint. One approach would be to actually take the derivative of each of these points, because in a sense what you're looking for is that point of maximum slope or maximum pH change versus volume of NaOH added. But we're going to take a more simple graphical method, which is perfectly adequate for the sort of data that we have here. So the idea is that we're going to be drawing two lines that correspond to how the pH would be changing if we were not actually reaching an endpoint, or if we hadn't actually had an endpoint. So I'm going to pick here my line drawing tool. So you would be doing this with a ruler, okay? And we're trying to find, sort of, in a sense, that line that corresponds to this data as the pH increases. And this would be pre-endpoint. Next, we're going to align a line that corresponds to how the pH would change post-endpoint. So this pH is changing merely because we're adding more and more NaOH. Then we want to take into account that drastic change in pH. And so we're going to draw another line that will run through the last data point after the drastic change in pH and the first data point before the drastic change in pH. So it'll look something like this. And effectively, what we're trying to find out is what's the midpoint between the intersection down here at the bottom and the intersection at the top. And so it is helpful to look at the graph and say, okay, we're at roughly a pH of 3 here, and up here we're at a pH of 11.8. So I'm certainly guesstimating here a bit. So we go from 3 up to 11.8. And so the difference here is 3 to 10, that would be 7, and that would be 8. So 8.8. So we're looking for, in a sense, a difference in pH of 4.4, starting down at the 3. So that would bring us to about 7.4, which is actually pretty close to a pH of 7, which is what you would expect the pH to be at the equivalence point of a strong acid, strong base titration. So we're going to try to draw another line that intersects at around a pH of 7.4 here. So I've got my line drawing tool. Now again, this is fairly crude, and you may be able to do a better job when you're actually using a ruler. So I'm just going to see if I can align this up a bit better, move it over, and I'm aiming to have it intersect at roughly a pH of 7.4. I want to draw down here, and I want to see, well, what would be the volume at that pH where there's maximum change in pH. So again, I'm aiming for a pH of around 7.4. I read downwards, and I can see that this line intersects with my x-axis, the volume of NaOH titrant. And I would, again, guesstimate that we're at around 7.8 milliliters. And so that would be the estimation of the experimental endpoint, which hopefully is an estimation of the theoretical equivalence point for this particular titration. I think that, given the crudeness of this sort of estimation, I would record this to two significant figures. So roughly about 7.8 in this case. Now, of course, your data will look different. It will correspond to your specific titration. So that would be for the first graph. I'm going to run through the same procedure for the second graph. When you see it twice, maybe it'll become a little easier to think about what you need to do. So now I'm going down to look at the graph that corresponds to the titration that involved our weak acid, the acetic acid, with NaOH. Once again, I want to draw the best fit line prior to reaching the equivalence point, or the estimation of the endpoint, prior to that drastic change in pH. And again, this is a bit of guesswork. You want to, in a sense, anticipate how was the pH changing prior to that drastic change in pH, and how would it continue if there wasn't a reaching of the equivalence point. And then post-equivalence point, or post-drastic change in pH, so something like this. And then draw a line considering the last data point before the drastic change in pH and after the drastic change in pH. So I'll extend those so that they intersect with my other lines. And then I want to find that midway point from this intersection down at the bottom and the intersection at the top, because the midpoint should represent the maximum change in pH per volume of NaOH added. So I'm looking, let's see, I'm starting roughly at about 6, and I go up roughly to 11, I'm going to say 11.6. And so that is 5.6 units of change. And so this would correspond to 2.8 units of change starting from the 6. So I'm going to go up to 8 and then 8.8. And so I'm aiming to draw a line roughly where the pH will be 8.8. And actually, that's pretty close to the expected pH that we would want for this weak acid with strong base. So let's see if I can draw a line that would intersect around roughly that 8.8 point. They're going to move it around a little bit until it intersects the pH at around 8.8. That's pretty close. Okay. And then now looking at how that particular line intersects with the volume of NaOH, and I might guess around 12.2. Again, in this case, it's going to be to 3 significant figures. In other words, to 1 decimal place is where we can estimate the volume of our NaOH that has been added. So what we have done here is made an estimation of the experimental endpoint and hopefully the theoretical equivalence point. For this sort of graph, we also know that there's something pretty important about the halfway point in the titration. So if this is 12.2, the halfway point would correspond to 6.1. So I'm going to draw another line here and line it up as best I can guesstimate at about 6.1 and see where this intersects with my line in terms of determining the pH. It's hard to know exactly where that would be, but I'm going to guesstimate it maybe somewhere about here. It looks like it's pretty much crossing the pH of 5.0. I might have expected, or I do expect, that it would be a little bit lower than 5.0, but again, the crudeness of our approach here, that's not too bad at all. And the theory tells us that at this halfway point in the titration, this is a very important point, because at this point, the pH is equal to the pKa of our weak acid. And therefore, this is a very nice method, if you have created such a graph, to guesstimate or try to determine the Ka of our particular weak acid. So I've already said that at this halfway point, I'm guesstimating the pH is around 5. I would have expected something closer to around 4.8, but you can see it's in the right ballpark. And this is something that you need to do to be able to make an estimation of the Ka of the weak acid that you used in your titration. Now, there's one last thing that I need to discuss with you. And so what I'm going to do is come back up here. You will see that in one of the questions, you are asked to indicate the pH range for 3 different indicators in Table 1 in the introduction of this labP. Because the idea is we want you to come to understand how you can choose appropriate indicators to follow the course of the titration without having to actually measure the pH. So the idea is, for instance, I'm looking at the bromophenol blue, and I see that its pH range is 3.0 to 4.6. So I want to actually indicate that on this graph. Now, you don't have to use any color coding and things, but if you have access to color pens and pencils, this might be helpful. For me, I'm just going to use a blue to represent bromophenol blue, but I could use other colors. I could use, if I transition from yellow to blue, but I just want you to indicate this range. Now, it starts at 3 and goes to 4.6. So I'm going to do something like this. So that's, I'll adjust it in a minute. Okay, so to adjust this, I want the range to more or less start at 3 and end at about 4.6. Maybe bring it down a little bit. Okay, so this is to indicate the range of my indicator, bromophenol blue. I can label this. So with my text, I'm just going to type in here, bromophenol blue. You should also do something similar for the bromothymol blue and the phenolphthalein. And what I think you'll find is that these ranges of pH change will match the pH range of drastic change in pH. So it should be that for a strong acid, strong base titration, any one of those 3 indicators would work quite adequately to be able to determine or make an estimation of the experimental endpoint, because they will be changing color just during this drastic change in pH. However, let's look at the next graph here. And for that same indicator, I am going to indicate, so this is going to roughly start at a pH of about 3 up to 4.6. And let's see if I can adjust this a little bit. So bring that up to 3. I may not be able to bring it down too much. There we go. It's kind of close to 4.6. Once again, I'll label. So this is the bromophenol blue. And if you notice how this particular range lines up with the particular titration here, and think about it, if you were to do this titration without monitoring the pH, but just monitored the color change of bromophenol blue, which essentially starts at yellow and ends up at blue, well, you would have stopped the titration halfway through the titration, because this indicator would have already changed color at a pH of, well, roughly halfway through the titration, or even be prior to halfway through the titration. And so I hope you get the idea that bromophenol blue would not be an appropriate indicator to follow this kind of titration. When you show the pH range for the other indicators, though, you may find that they align better with this drastic change in pH, and you may come to the conclusion that they are adequate for monitoring a weak acid, strong base titration. I hope you have found this video to be helpful, and I thank you for your kind attention.